Question 1.1.1 states, sketch the graph of y equals minus the root of 9 minus x squared. It is important for us to note that a question like this only counts 3 marks. Therefore, if you memorize the different functions of graphs, how each graph looks, and how to sketch it thereof, you can do that. Since if you do a lot of steps to draw a graph, you will not necessarily get a lot of marks for the steps that you've taken. However, if you do not want to remember and memorize all the different types of graph and how each one works, a general safe practice will be to use a method such as calculate the x-intercepts, the y-intercepts, and if you cannot calculate them, to use a table method. But again, noting that this might not count marks for us. So the first thing that I'm going to do is I'm going to see whether or not, if I try to sketch this graph, can I first of all calculate the x and the y-intercepts. So I'll start off with the y-intercepts. So in order for me to calculate the y-intercept, I'm going to set my x as 0. So for the y-intercept, x equals 0, which means where there's now an x, I'm going to put in a 0. That means that y equals negative the root of 9 minus 0 squared. That means that y will be negative of root 9. And root 9 we know to be as 3. So my y-intercept will be negative 3. So I was able to calculate my y-intercept. Will we be able to calculate our x-intercept of this graph? So x-intercept, and for x-intercept we set y equals to 0. So for x to be 0, or for y to be 0, we'll have 0 equals negative the root of 9 minus x squared. So the first thing that I have to do is I have to get rid of the negative. So to get rid of the negative, I multiply throughout with negative, taking the negative to the front of my 0. So I'll have negative 0 equals the root of 9 minus x squared. Now, however, in this example we have negative 0, and we know that a negative does not impact my 0, so it would have just remained 0 in this instance. So the next thing that we have to do is I have to get rid of the root. So to get rid of the root, I square both sides of the equation, meaning that 0 squared, whether it's negative 0 or 0, 0 squared will then be 9 minus x squared. And again, remember that we cannot split the root of 9 minus the root of x, as that is one function within the root. So we had to square both sides of the equations to get rid of the root. So the next thing I want to do is I want to have my x to the one side of the equation and my number, in this example 9, to the other side of the equations. So since my x is negative on this side, I'm just going to bring it over to this side. So I'm going to have on this side x squared equals, and I'm going to have 9. Again, to get rid of my x squared, I'm going to do the root of both sides, making it so that x equals plus minus, since we're doing the root, plus minus 3, since we know that the root of 9 again will give me 3, meaning that my x-intercepts will be positive 3 and negative 3. So now we have our intercepts. We can go over to drawing our graph, or sketching the graph. So in order to sketch the graph, when doing it on during examinations or test, we will do it to scale, and we'll try to have it as accurate as possible. However, for the purposes of this, I'm just going to sketch it freehand for us. So we'll have our axis available. And again, remember to always label your axis and to label your graph, as you will get marks allocated for that. So we know my y intercept was -3. So at -3 my graph is going to cut. Then I know my x-intercept was +3 and -3. So now it's going to cut at +3 and it's going to cut at -3. So that means my graph will go through those 3 points like that. And remember to, again, always label your graph. So in this case, we're going to have y equals negative the root of 9 minus x squared. Okay, and that is question 1.1.1. Question 1.1.2 asks, is the graph a function or a relation? So again, we said with determining a function or a relation, the method that we use for it is we draw a vertical line parallel to the y-axis anywhere on the graph or multiple lines, and see how many times does this line that I draw straight cut through my graph. So in these two lines, each of them just cuts the graph once. So it doesn't matter where I draw it, I only have one place where it cuts over the line. So we said a function is when it cuts just one place, so it just functions. However, for a relation, it is 2 or more times. So if we look at this graph, again, it cuts over once, meaning that this will be a function. So for question 1.1.2, the answer will be a function, since there is only one y value for every x value.